learning target, and it's kind of big, so I'm going to have to scroll down so you can see the whole thing. I can identify and discuss vertical angles. I can recognize that they are equal to each other, like their angle measure is equal, and they must share a vertex and both sides. So how's that different than what we did yesterday? What did adjacent angles share? Oriana?
Adjacent angles only shared a vertex and one side, not both.
They shared a vertex and a side. What was the other kind of gray rule about vertical angles? My rule is kind of different than Pearson's.
They can't be inside of each other.
Yeah, not that they can't, but we prefer them to not be. That's where, and if you did last night's homework, you probably noticed that a couple times they used adjacent angles where one was inside of the other. Yeah. Technically, you can. They share a vertex and they share a side, so they are adjacent. But when we talk about adjacent as like the literary definition, it means next to. So we try to keep those angles next to instead of one inside of the other. So if we look, oh, we're not vertical angles there. We're complementary. I got ahead of myself. So complementary angles, I'm going to change that learning target. What did I bring up yet? Complementary and how I remember the relationship.
Yeah, but no. Yeah, you did bring that up. I think the first day.
What do they sum to? Two complementary angles when joined together. How I remember it is to complement someone is the right thing to do because they sum to 90 degrees. And they actually don't have to share a vertex or anything like that. You can have complementary angles that aren't connected. So what's weird about that is we normally see them connected. And I have a picture that I'll try to dig up at the end of class. Actually, we'll see if I have it. This video is going to be really bad. If I go back to last year.
Really? Last year?
It may not be. Oh. Ah, crap. At home, my wife and I made a picture frame to go around one of our mirrors. And the mirror was kind of crappy because it had been in the bathroom for a long time, and like one of the folders, or one of the corners of it started to kind of get messed up. This is all foundations, taking a risk.
You should take a picture of mine, take a risk.
I do sometimes, man.
Oh, okay. Maybe.
Nope. So, this launch, though, does a good job at showing what we had to do with the picture frame. If you assume that the mirror is like right here, and we wanted the frame to go all the way around it, but we needed the frame to cover up that part of the mirror that was flaked off, because you guys know how a mirror actually works. A mirror is just clear glass with
silver painted
with silver painted on the back of it. It's like a reflective, or it's just stuck on the back of it. Now sometimes they just use adhesive things, but it's just clear glass with something on the back of it. So the back of it was like flaked off down here, so we wanted to cover it. So we made a frame that went all the way around it, and it's probably about 4 inches thick. Now at the corner of each of those frames, or at each of the corner of the frames, you could either have the boards meet like that, they'd meet square in a 90-degree angle, but that looks ugly. When you look at something that's been like joined up like that, your eyes, like visually, you see that it doesn't look how it should or as nice as it should. So instead, we decided to cut it at an angle. Now, if you cut your angle incorrectly and you don't do the math, you're going to end up with something like this, where there's a gap between the two pieces. So when you correctly cut it, and you want each of them to be the exact same angle, which complementary angles don't have to be the same, but if we're trying to make something look good, we're going to make them the same. What would two equal complementary angles be? What would each one have to measure? Thomas?
Each one would have to measure 45 degrees.
Yeah, each one would have to measure 45 degrees. And I cut both of those, and you should probably write that in here. I cut both of them at 45, so that angle was 45. This angle was 45. And together, they made a total of 90. That's what it means to be complementary. To equal 90. When you sum, it's a pair that sums to equal 90. So, would these two yellow angles here be complementary angles? No, there's a gap between them. One of the angles was cut too small. So, by the looks of it, I think this piece is 45, but maybe this piece they accidentally cut at like 35. They used their protractor wrong or something. Somehow, their angles do not add up to 90. This is not complementary. This makes sense? Now, about halfway down your page, a little bit more than halfway, right under the hole punch, you can remember this, ... I would highlight or put a star to that or something so that when you're doing your homework, if you repeat that in your head, you will remember it long term. To complement someone's the right thing to do. Because the other set of angle pairs, anyone know that name for the other set of angle pairs? Supplementary. Anybody know something to remember that by? I'm always curious because some 6th grade teachers give you guys some really cool ways to remember things.
I've never used these kinds of angles before, so.
Anyone know why somebody would take supplements?
To be healthy.
Supplements are like extra vitamins or extra nutrients or extra protein. So what happens when you get stronger? Your muscles grow. So you take supplements to get bigger. So supplementary angles pair up to 180. Whereas complementary angles, since to complement somebody is the right thing to do, so this is what I would highlight or put a star next to or something so that you remember complementary angles sum to 90. Sick.
No, Franny's here today, actually. It's not really.
There's been like flu and different things going around. So, complementary angles do not have to be equal. I could have an angle of 1 degree, and the complementary angle to that would be 89 degrees. So when we think about
two angles are complementary angles if the sum.
Stop. So we want them to make a right angle. So the first situation we look at is a 45 and a 45. This is your perfect, even, nice way to cut an angle and piece together 2 pieces of wood or anything like that. Now, if we want to make a little bit more difficult, we move this point B downward and make that lower angle smaller. So when we do that, I can make it 40 and 50. That'll be another example of a complementary pair. Because if I'm only moving my B and my A and my C stay in the same locations, AOC stays a right angle. So when I move B, all I'm doing is making my lower angle smaller and my upper angle bigger. So another example is, if you'll stop there, 30 and 60. You can kind of see that. It is on your paper, but in a different way. And then they don't have to be adjacent to each other. So they do not have to be touching. They do not have to share a vertex. They actually don't have to share anything. So all that we care about, bless you, is that they sum to 90. Bless you. Are you allergic to math today?
No.
So here's another example of complementaries, but they're not touching. So I would, on your notes, over here, I would write, don't have to touch. They can, but they don't have to. Yeah, we may actually start our next lesson. And if we start our next lesson, then I'd be more inclined to give you guys a work day tomorrow. So I want you to draw adjacent. So now I'm asking you to draw them touching. and label how big it is to be the complement. When we ask for a complement, it's looking for the other angle. So in angle A, Zach, what would be the size of the angle that's the complement to that?
20.
What's it got to add up to?
90.
It's got to add up to 90. So 80 plus what?
10.
10. So I have two options. I can draw the angle up here and label it, and we can draw an arrow into it to label 10 degrees. Or I could draw it on this side and label it 10 degrees. So we always have two options where I can draw my angle. So either of those are complementary. I just shuffled and you ended up on top again, Zach. Karina, what about B? How big would that have to be complementary?
70? No.
Careful.
60?
60. So we finish out the right angle, and you can kind of try to see the right angle in the corner. But then I only want to label, I'm just going to erase that whole thing. I only want to label the angle that I drew, and we can label it 60 degrees. And Brennan, what about C there? How big would that complement have to be? 45. Be careful because, and we just saw it happen twice, your brain wants you to go to 100. Your brain is like, oh, 100 is nice, it's 100, but that's not, with angles, 90 is half of a rotation, it's a quarter turn. So complementary angles make a quarter turn together. So, two angles that are not complementary here. Name two angles that are not. Now, remember, you have to name them with the 3-point naming. We'll call on a couple people. Ethan, I haven't talked to you yet today.
BFC and DFE.
So hold on. Angle BFC and angle what? DFE. Why'd you choose those?
Because they're both 15 degrees.
They're both
Each
tiny.
up to 13.
This angle and this angle definitely are not complementary. Now there's another set that's easy to identify. Brennan? Or Luke, sorry.
AFE
So you have 75 degrees right now. You cannot choose a 15-degree angle.
CFD or DFE.
CFD, sure. Now here's the thing that I think some of you aren't yet realizing. Thomas?
AFC.
Yeah, thank you.
Anything.
AFC and any other angle. But if we want to get really creative, let's use CFE, and these are actually supplements. They are supplementary to each other because AFC is right here and CFE is right there. They're both 90. That would actually be a supplementary pair, but it's not complementary. We could choose a lot more because some of you guys aren't realizing this yet. Smaller angles combine to make bigger angles. So we do have 4 small angles up here, but I have a lot more when I start combining them. Because think about if I combine all 3 of these angles together, that's a new angle, AFD. I could also combine these 2 angles together, get a bigger angle. I could combine these 3 angles together, get a bigger angle. I could combine these 2. There's so many angles available to be made here. It's every smaller angle can join up with another angle, make bigger angles, as long as they share the same vertex. If people don't watch the video, that slide is not going to make any sense. Your friend claims that all complementary angles, so each angle that is used in the pair, must be acute. Are they right? Get it? Are they right? Trina, what do you think?
I don't get it.
I would think that they're right, maybe because since it has to equal 90, anything less the 90 is an acute angle.
Yeah, if, let's say we have angle A and angle B, and they're going to equal 90. They're a complementary pair. We have two things together that equal 90. What we know is that angle A has to be less than 90, and angle B also has to be less than 90. Because otherwise, they're going to add up to more than 90. If angle A was 90 and B has a value, they can't be, well, it has a value that is a real value. This could not add up to 90. So yeah, they're totally right. Your friend, this time, like a complementary pair, is right.
But on the first time ever, I thought it was going to be like some serious question.
Yeah, your friend is normally struggling. So, if you really want to make your parents like grown and, you know, remember things, or if you have older siblings, if there's ever a situation where you're asked, are they right? You can respond with, yeah, you're a complementary pair. And it's really lame, but it's really lame, but
These are really bad math.
I do that stuff to my wife and she just rolls her eyes at me. Social cues, like we were talking about this morning, when somebody rolls their eyes at you, you probably are doing something inappropriate or making bad jokes. So, here we go, angles 1 and 2. Now remember, when we name angles with numbers, the numbers aren't actually numbers. They're just placeholders. You might as well say angles purple and blue. They do not matter what their number is. So angles 1 and 2. Oh yeah, I tweaked these. Sorry, this, I tweaked the notes. Or when it printed weird. That got it went on the front part, so make sure you have it for the got it. Angles 1 and 2 are complementary angles, and angle 1 is 24. If angle 2 is 3x, well, I'm going to label these things because I get confused really quick. So that's 24. This angle's 3x degrees, and we know they're complementary, so they add up to 90. So set up an equation. We've got 3x, we've got a 24, and we know they have to equal 90. Katie, what would I do? She left. Bella, what would I do first here? I get rid of my constant by subtracting 24 off of both sides. Then 3x will equal 66. Because remember, you subtract the 20, then subtract the 4. So then, Brennan,
22.
oh, tell me what to do. Divide by 3, which then gets me the answer of, thank you, Brennan, 22. Questions on that? Pretty straightforward, right? Try the got it on your own. This is even easier because it's only a one-step equation. Divine, what do you think? Okay. Sorry, you were like way high out of your chair, so I figured you would want to answer. So we know that these are complementary because the right angle is on there. So the equation that we could set up is x plus the 47.6 will equal 90. So that's the first thing that we want to write is x plus 47.6 equals 90. If you're done, check with a neighbor. See if they got the same thing that you got.
Yes.
So then to get the x by itself, you get rid of the 47.6. You subtract that on both sides, we'll have our answer. The equation that you should have is x plus. Luke, give it to me.
42.4.
Oh, come on. I didn't want the answer. I wanted the equation.
Oh, you subtract 47.6 on each side, which is...
Hey, guys, bring it back together. Luke's talking us through this. We subtract the 47.6 on both sides, and we get, again, give it to me, 42.4 degrees. Any other questions? Do you think we need to do more practice with this, or do you think you're pretty good? Think you got it?
It's just like 1 plus 1.
It's just like 1 plus 1.
It's easy as ABC.
Easy as 1, 2, 3. Go, Ray.
That's easy as
All right. If you're at home playing along, we're gonna go ahead and do another lesson today. So I'm gonna stop this video and I'm gonna start a new one for 10-4.